Welcome dear students in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra. Today we are going to discuss a chapter of 11 science, that is electromagnetic waves and communication system. As long as this chapter is concerned, this is a lecture number 1. So, dear students, be alert to listen this chapter very carefully, to listen this first lecture very carefully, that you can able to understand the basic concept of electromagnetic waves. Okay. So, before learning directly the electromagnetic waves, we have to learn some introductory part. I will write on the board. Introduction. What is introduction? So before going directly, you should know what is meant by wave. Wave is a oscillatory disturbance propagating through the medium, like this. See here, oscillatory disturbance propagating through the medium, like this. This is an oscillatory disturbance propagating through the medium without change of form. We call it as a wave. That there are two types of waves that we have already learned. The first is transverse wave and second one is longitudinal wave, dear student. So what is transverse wave? A wave in which vibrating particles of the medium are perpendicular to the direction of propagation of wave. Suppose this is the direction of propagation of wave. Particles of the medium are oscillating up and down. Remember well, dear students, particles of the medium cannot travel along with the wave. Particles of the medium only oscillate up and down like this to its main position. So, vibration of the particles of the medium is perpendicular to the direction of propagation of wave. Such a wave we call it as transverse wave. Wave propagating through the rope is called as transverse wave. Then we have already learnt longitudinal wave. What is longitudinal wave? Sound wave is a very well-known example of longitudinal wave. In longitudinal wave, vibrating particles of the medium are parallel to the direction of propagation of wave, like this. Direction of the propagation of wave is like this, and vibration of the particle is like this. See here. This is vibration of the particles. Compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction. That means vibrating particles are parallel to the direction of propagation of wave. We call it as longitudinal wave, no doubt. Okay. Then we are globally connected to television, internet, cell phone, or we call it as mobile, and all the signals of that gesture is traveled from one place to another place with the help of EMW wave, that is electromagnetic wave. So electromagnetic wave, dear student, is a very responsible factor to transfer such a signal from one place to another place. And so that what is electromagnetic wave and how electromagnetic wave is produced, what is the main source of electromagnetic wave? This is a very interesting, funny questions we will have to discuss today. So before learning this, let me clean the board at first. So I will clean the board. After learning this introductory part, I will write 13.2.1, and the name of the article is Sources of EMW, electromagnetic wave. Very interesting, electromagnetic wave. So before learning directly the electromagnetic wave, listen carefully, dear students. Remain alert up to the end of this lesson. The first sentence that I have written on the board is changing magnetic field induces an electric field. I will write that. Change in magnetic field. Change in magnetic field. Change in magnetic field induces an electric field. Electric field. So what is this concept? What is this concept? Let me draw the diagram at first. Suppose like this. I have taken a circle, and inside the circle, this is the direction of magnetic field like this. Don't bother. It is magnetic field. The symbol of such a cross is nothing but the magnetic field is directed inward into the board. This is the symbol. Cross line is the direction of the magnetic field is inward. And if we write like this, such a symbol like this, direction of the magnetic field is directed outward. Listen carefully. This is the symbol of to show the direction of the magnetic field directed inward, perpendicular to the board. And this is the symbol to show the direction of the magnetic field directed outward, perpendicular to the board. So I have shown magnetic field which is directed inward, perpendicular to the board. Okay. If I increase the magnetic field, magnitude of magnetic field, if the magnetic field increases, then what happens? See here. Suppose this is the outer region like this to show some another physical quantity. If the direction, if the magnitude of the magnetic field increases more and more, magnetic field increases, there is a change in magnetic field. This change in magnetic field, remember well. Before explaining this diagram, I want to dictate you one thing. These four fingers suggest the direction of the magnetic field. Listen carefully. These four fingers suggest the direction of the magnetic field. This thumb suggests the direction of the electric current, direction of the electric field. Direction of the electric field, direction of the electric current is shown by the thumb. And these four fingers suggest what, dear student? These four fingers suggest the direction of the magnetic field. As soon as there is a change in magnetic field, what happens? That I want to explain in front of you. Direction of the magnetic field is like this. Direction of the magnetic field is like this. And so that direction of the current is produced, and that current, direction of the current is like this. Direction of the current is like this. Direction of the magnetic field is like this. So direction of the current is like this. Direction of the current. Direction of the current, that means current is induced in the circuit. As soon as there is a change in magnetic field, current is induced in the circuit. Because electron is moving opposite to the direction of electric current. Direction of electric current. Electron is moving opposite to the direction of electric current. And so that electric current is flowing like this. And in this way, change in magnetic field induces electric field. Because there is an charge, the production of negative charge. As soon as the current is moving like this, it clearly indicates that electrons are always opposite to the direction of the current, and as soon as there is a moving charge, there should be a production of electric field. So most important sentence we must remember in our mind that the first sentence I have already written on the board is change in magnetic field induces an electric field, and this is called as Faraday's law that I have written here, Faraday's law. Then observe the next sentence. What is the next sentence? Changing electric field induces an magnetic field. That means electric field and magnetic field are not independent. They are associative with each other. They depend with each other. Electric field and magnetic field both are two brothers. Both are two sisters. They depend on each other. They are not independent. They are not separated. Remember this sentence. Remember this concept, dear student, in our mind. So let me clean the board to explain the second sentence. What is second sentence? Change in electric field induces an magnetic field. I will clean the board at first. I will clean the board at first. And then I will write here. What is the next sentence? The next sentence is change in electric field. Changing electric field. Changing electric field. Change in electric field induces an magnetic field. And magnetic field. For that purpose, take an example of condenser like this. See here, this is a condenser, and this condenser is connected to a battery. Suppose the key is open initially. See here what happens. This is positive, this is negative, and this is a capacitor, parallel plate capacitor, and that capacitor or condenser is connected to a battery as shown in the figure. As soon as the key is closed, then what happens, dear student? Positive and negative charge start inducing onto the two plate. Here positive charge, here negative charge. In the next time, here positive charge, here negative charge. After some time, again positive charge, negative charge. After some time, again positive charge, negative charge. That means charges are induced gradually with time along the two plates, and so that electric field starts increasing, and the direction of the electric field is like this, from positive to negative, positive to negative, positive to negative. This is the direction of the electric field. As long as the charge starts inducing, that induced charge start increasing with time, electric field also increases. Electric field starts increasing from positive to negative, and direction of the electric field is from positive to negative terminal, from positive to negative plate, and this electric field creates displacement current. This is the most important concept, dear student, displacement current. What is displacement current? When the condenser starts charging, and when it is fully charged, at that time there is a change in electric field, and direction of the electric field from one plate to another plate is as shown in the figure to produce displacement current, having direction like this. So thumb indicates the current, thumb indicates the current. As long as the current is there, there is a production of magnetic field. Magnetic field is producing like this, outward to inward. So here the direction of the magnetic field in upper case is like this, and direction of the magnetic field in downward case is like this. So as long as the electric field is generated, the direction of the electric field is like this, Direction of the electric current is like this. Direction of the magnetic field is from outward to inward. That means the direction of the magnetic field is like this. Direction of the magnetic field is like this. And direction of the current is like this. So change in what? Change in electric field induces magnetic field. In the first example we have seen changing magnetic field induces electric field, that is Faraday's law, and this diagram suggests changing electric field induces magnetic field. This is called as Maxwell's law. So from these two experiments we drawn two conclusions, three conclusions. The first conclusion is, you should write in your notebook that conclusions what we made. I will write on the board. Let me clean the board at first. Let me clean the board. Be remain up to the end of this lesson. That will, your idea will be clear cut. What is electromagnetic wave? So the first conclusion is number 1, change in magnetic field. Changing magnetic field produces an electric field. Number 2, it is called as what? Faraday's law. The number 2, changing electric field induces, or we call it as produces what? Produces magnetic field. Electric field is denoted by E vector and magnetic field is denoted by B vector. From the two experiments we have also drawn another most important conclusion, dear students. This electric field vector and magnetic field vector is perpendicular to each other. See here, in the second diagram, the electric field is like this, magnetic field is like this. Electric field is like this and magnetic field is like this. Electric field is like this. Electric field is like this, electric field is like this, magnetic field is like this. In the first diagram, magnetic field is like this and electric field is like this. So magnetic field and electric field is perpendicular. Faraday's law. In the second, magnetic field and electric field is perpendicular. So in both the cases, remember well, electric field vector and magnetic field vector is always perpendicular to each other. What is the conclusion? Electric field E vector and magnetic field B vector are perpendicular to each other. Okay. Take a screenshot. These are the 3 most important conclusions that we have drawn by listening to simple experiments. So take a screenshot. Screenshot. Okay. Then we will proceed further. We see 3 cases. Three cases. The first case is what? We see 3 cases. The first case is what? Number 1, charge at rest. Number 1, charge at rest. Suppose this is a plus Q charge which is at rest. What happens? Is it this charge produces electric field as well as magnetic field? No. Magnetic field is produced if and only if charge is moving, current is produced. So this is a steady charge which produces only electric field like this. direction of the electric field outward to produce electric field only, to produce electric field only. So this is number 1. Number 2, charge with constant motion. Charge with constant motion. If the charge is moving constantly like this, there is no acceleration. As long as there is a motion, there is a production of current. And as long as there is a production of current, there is a production of magnetic field. So here, constant electric and magnetic field is produced. As soon as there is a charge produces electric field, current produces magnetic field. So constant electric and magnetic field is produced. I will write here. Constant electric and magnetic field is produced. Constant electric and magnetic field is produced. And what happens in the third part? I will write here, third part. If the charge is accelerated, that means this plus q charge is moving with acceleration, increasing velocity or decreasing velocity. Charge is moving with acceleration. That means velocity changes time to time. In this case, due to charge, there is a change in electric field because it has acceleration, time varying electric field. And due to current, that current increases or current decreases, either increases or decreases, we get time varying magnetic field. Very important sentence, dear student. In the third case, as soon as the charge is accelerated, velocity continuously changing with respect to time, no doubt we get electric field and magnetic field, but we get time varying electric field and time varying magnetic field due to the acceleration of the charge or due to the accelerated charge. That I will write here. We get time varying electric field and time varying magnetic field. Concentrate this sentence, time varying electric field and time varying magnetic field. In which condition we get time varying electric field and time varying magnetic field? Only if and only if the charge is accelerated. So acceleration of the charge produces time varying electric field and time varying magnetic field. And we know in all the cases electric field and magnetic field are perpendicular to each other. And to produce electromagnetic wave, time varying electric field and time varying magnetic field is necessary. Remember this sentence up to the end of your education. To produce electromagnetic wave, we require time varying electric field and time varying magnetic field, and this time varying electric field and time varying magnetic field are produced by the accelerated charge. So accelerated charge is a father of electromagnetic wave. Accelerated charge is a father of electromagnetic wave. So before going forward, take a screenshot at first. Take a screenshot. Take a screenshot. Take a screenshot. Take a screenshot. Okay. Then we made conclusion that time varying electric field and time varying magnetic field is responsible factor to produce electromagnetic wave, and this time varying electric field and time varying magnetic field is produced by the accelerated charge, and so that accelerated charge is a source of EMF. That's all. And from that we prepare the definition of electromagnetic wave. Definition of electromagnetic wave. Definition of electromagnetic wave. Definition of electromagnetic wave. Okay. We will write electromagnetic wave is a wave produced by accelerated charged particles which consist of time varying electric field E vector and time varying magnetic field B vector, which are not only perpendicular to each other but also perpendicular to the direction of propagation of electromagnetic wave. Time varying electric field and time varying magnetic field both are perpendicular to each other. See here how the electromagnetic wave is moving. This is a time varying what? Electric field. This is a time varying magnetic field, and direction of the propagation of the wave is like this. This is the direction of the propagation of wave. See here, time varying electric field. This is a time varying electric field. This is a time varying magnetic field. Time varying electric field and time varying magnetic field, they are perpendicular to each other, and the journey of myself is the direction of propagation of wave. Direction of propagation of wave. This is called as electromagnetic wave. Direction of the propagation of wave is like this. Time varying electric field is like this. Time varying magnetic field is like this. So time varying electric field and time varying magnetic field both are in the same phase. No doubt their plane of vibration is perpendicular, but phase difference between time varying electric field and time varying magnetic field is zero. Time varying electric field and time varying magnetic field, they are looking perpendicular. That is, they vibrates in a perpendicular plane, but their phase is zero. Phase difference is zero. They are in the same phase like this. They are in the same phase. They are in the same phase. They are in the same phase. Maximum amplitude, minimum amplitude. Maximum amplitude, minimum amplitude. Maximum amplitude, minimum amplitude. And how the diagram is drawn of electromagnetic wave, that we will see. So take a screenshot of this definition. Take a screenshot of this definition. Electromagnetic wave. Okay. How we can draw a diagram? how we can draw a diagram. Very funny, very interesting, electromagnetic wave. How we can draw a diagram? The diagram is like this. Suppose this is a y-axis, this is a x-axis, this is what z-axis, like this, z-axis, this is y, this is z, and this is x. So this is the time varying magnetic field. This is a time varying magnetic field. Magnetic field goes on increasing like this. Magnetic field goes on increasing like this, goes on decreasing like this. And because of this changing magnetic field, we get change in electric field like this. Like this. See here. This is the direction of the electric field. Along the z-axis, and due to this change in electric field, we get change in magnetic field again. That change in magnetic field we get in downward direction like this, change in magnetic field like this. This is on y-axis, along y-axis like this. And due to this change in magnetic field, we again get change in electric field along z-axis like this, like this, like this. Like this. Again we get what? From this we get what? Magnetic field. That magnetic field we get like this. Magnetic field is like this. And from this we get what? Electric field. The change in electric field is like this. So here, electric field is like this, magnetic field is like this. Change in magnetic field I have shown by the black loop on y-axis. Change in electric field I have shown by the red loop along the z-axis. And this is the direction of propagation of this x-axis, suggests the direction of propagation of electromagnetic wave. This is the wave nature of electromagnetic wave. This is a magnetic field. This is a magnetic field. This is what? This is electric field. Electric field is on z-axis. Magnetic field is on y-axis. Z-axis and y-axis is perpendicular. Suppose z-axis is like this. Imagine z-axis is like this. So electric field is like this. Magnetic field is like this. Like this. See here. This is magnetic field. This is electric field. This is magnetic field. This is electric field. And what this? This is the direction of propagation of wave like this. Direction of propagation of wave. Both are oscillating like this. And direction of the propagation of the wave is like this. This is called as electromagnetic wave. This electromagnetic wave, the velocity of the electromagnetic wave is very fast, which is equal to the speed of light 3 into 10 raised to 8 meter per second. To propagate electromagnetic wave, material medium may or may not be necessary. That means electromagnetic wave can propagate through vacuum also. Okay, we will stop here and continue in the next lecture. Till now, thank you very much. If any doubt, then you can ask by making a message in the YouTube channel. Okay.